So we've talked about how to multiply. In other words, if I'm given this, if I'm given these side lengths here and here, there's some different pictures I could think about, different procedures I could use to get down to the multiplication. Like this times this side length times this side length is that. In other words, that's the area of the inside spot. So the question is, how do I undo this? In other words, if I'm given this, how do I get that? And what we could do is we could take tiles and start to use them like puzzles. We did that in class quite a bit. And then just, how do I make the rectangle? And if I need to add in some zeros to fill it in, how do I do it? But we get to a point where we start looking at this generic rectangle and looking for some patterns in here. And one of the things that I notice is like this x squared is here, and this -8 is here. And it's like that always happens. Like this first term is up here, this last term is here. And then the other thing that I notice is that if I add these together, I get the middle term, right? That's where the middle term comes from, is those two pieces added together. So it's kind of interesting that I need things that add to this. But then let me think about where this 4 and this -2 came from. And it's pretty, I think this is really interesting then to think about just this thing that happens right here. If I look at this diagonal and I multiply them together, -8 times x squared is -8x squared. And then if I look at this diagonal and I multiply them together, -2x times 4x is also -8x squared. So notice that like the multiply to this, like this times this has to be the same as that times that. But these also have to add to that. So in other words, if I'm looking at this, I need numbers that multiply to this, -8x squared, but then also add to that middle term, to that 2x. Let me think about this. What multiplies to -8x? -x and 8x, -2 and 4x, and I could list them all. Sorry, -2x. But notice I found it right here. 4x plus -2x is 2x. Oh, that's that. Then I've got these pieces. I can put them in there and go on my way. So I'm going to do some problems like this. But again, notice the thing that I'm looking for is things that multiply to this and add to that. So let's get up here and see what happens. So let's grab one. So here's the area, and I want to find the side lengths. I want to find the multiplication. In other words, I'm factoring. I'm undoing multiplication. So let me set this up. Let's see. I've got an x squared. I've got a 12. It's going to go here. And then now, this times this is 12x squared. So I need things that multiply to 12x squared, because remember, this times this is the same as that times that. But I also know that the things that are here and here will combine to give me that 7x. So it's also going to add to 7x. In class, we spent a lot of time building up this relationship. It doesn't come out of nowhere. So let me think about factors of 12x. I've got x and 12x. I've got 2x and 6x. I've got 3x and 4x. That's it, right? Those multiply to 12x squared and add to 7x. So here's what I'm going to do now. The 3x and the 4x, I'm going to put them here and here. It doesn't really matter which one I put where. I'm going to put this one here. I'm going to put that one there. And then now I'm going to look across. Let's see, x squared and 3x. They have an x in common, so I can factor out an x. That means if that's an x, this is an x. Remember, these are going to multiply, so this must be a 4. Notice 4 goes into both of those. And this must be a 3. So now this factors to x plus 3 times x plus 4. And it is fully factored. So notice that if I'm going this way, if I'm given the area and I figure out what the side lengths were, I'm factoring. But if I'm going the other way, if I know the side lengths and I'm finding the area, I'm multiplying. Multiplication, boop, and division. They do and undo each other. So notice this was when that leading term was 1. And let's, there's a lot we could do like this. Let me grab another problem. I have a collection of them down here somewhere. All right, here's one. Let's grab this one right here. That's in the middle. So set it up. I've got x squared. I've got -100. Multiply these things together. So I've got negative 100x squared. So I want things that multiply to that, but add, again, to that middle term, negative 21x. So we've done a lot of this in class, a lot of this practice. So things that multiply to negative 100x squared, let's see, x and negative 100x, that doesn't add to negative 21. You might see it right away. I'm just going to be methodical about it. 2x and negative 50x. Nope. 3, no. 4x and negative 21x. 25, sorry. I think I anticipated the answer there. There it is right there. Those add to negative 21. So I can put them wherever I want up here. I'll put the 4x here, the negative 25x up here. And now, let's see, look across here. There's an x in both of these. So this must be an x. X times x is x squared. X squared times what would give me negative 25? Well, negative 25. X times what would give me 4? 4 times. Yep, there it is right there. So this factors to x plus 4 times x minus 25. Now what I want you to notice is we've just had this leading coefficient, the x squareds, as 1. We've just had 1x squared. So earlier I did a video where I did this multiplication and I got this answer. You know, it's the same exact process. So I'm going to come up with a question here that should work, that we could factor where that leading coefficient is not 1. So we are going to factor this. All right, let me set it up. Beep, bop, boop. 2x squared, that first term goes here. Last term is going to go here. And so then now I want these that are here to add to 11x. But notice if I multiply these together, I get 10x squared. They also have to multiply to 10x squared. So I'm going to list some factors of, so I want things that multiply to 10x squared and add to 11x. So then, like I was saying, I'm going to list factors of 10x squared. So I've got x and 10x. I'm not going to check. I'm just going to list them all right now. 2x and 5x. That's it. Unless I go, you know, negative x and negative 10x. But these two add to 11x. So that means those are my pieces. I can put one wherever I want. I'll put 10x here and x here, say. Okay, so now I'm going to look across. So now these both have an x in them. But notice there's a 2 and a 10. These are both divisible by 2. So I could factor out that 2. You can think of that as the greatest common factor of those things. So this is a 2x. So this must be an x because 2x times x is 2x squared. X times 1 is x. This must be a 5, right? 2x times 5 is 10. 5 times 1 is 5. So this factors to x plus 5 times 2x plus 1. Again, just the side lengths of it. Let's do one more, one that's just a little more challenging, just to see how ridiculous these can get. Minus 27x minus 6. All right, let's set this thing up. Beep, bop, boop. 15x squared, there's the first term. Last term's here, negative 6. Now, if I multiply those together, 15 times negative 6, that's negative 90x squared. So I'm going to need things that multiply to negative 90x squared. But remember, they will add, because they're here and here, to negative 27x. Negative 27x. Add. Okay, let's start getting some factors of negative 90x squared. So x and negative 90x. Let's see. 2 doesn't go into it. 3 does. 3x and 27 divided by 3, negative 9x. Is that right? Oh, shoot. I'm going the wrong way. I'm going into 90. So 3x and negative 30x. Okay. Oh my gosh, we got it early. Negative 27x squared. If you don't see it, you keep going, right? Like, does 4 go into 90? Nope. Does 5 go into 90? Yep, it sure does. Like, you could list them all, right? 5x minus 18x till you find it. But I like to check it as I go, save myself some work. So I'll put the 3x here. I'll put the negative 30x here. Doesn't really matter what I put where, as long as one's here and one's there. Okay, I look across this way. Notice these both have a 3 in them, the 15 and the 3. So 3x, right? That goes into both of these. If this is a 3x, well, this must be a 5x. If this is a 5x, that's a negative 30, so that must be a negative 6. This must be a 1. So this would factor to, it's equal to 5x plus 1 times 3x minus 6. This actually tells me I could have factored something out to start with, but that's okay. We will let that sit.